Hello and welcome. Today, we're going to completely change how you think about fractions. Seriously. We're moving away from the kitchen table and onto a kind of map. A map for numbers. Okay, let's dive right in.
We all learned this one in school, right? A fraction is just a slice of a whole. 1/8 is one slice of an 8-slice pizza. It's simple, it's visual, and for a lot of us, it's kind of where our understanding of fractions begins and, well, where it stops.
But what if I told you that only thinking of fractions as pieces of something actually holds us back? That simple pizza model, it has some pretty big limitations, because fractions aren't just parts of a whole. They are actual, real numbers, each with their own specific address.
And to find that address, we need a new tool. So, forget the pizza cutter, we need a map. And in the world of math, our map is the number line. Think of it like a perfectly straight road where every single number has its own unique spot. For our journey today, we're going to focus on one really important stretch of this road, the space between 0 and 1. This is where most of the fractions we use every single day live.
So, to use our map, we need directions. And the first direction comes from the denominator. That's the bottom number of the fraction. The denominator tells us how many equal-sized parts to cut our little road into between 0 and 1. So if the denominator is 4, we make 4 equal sections. Simple as that.
Our second direction comes from the numerator, which is the top number. So once we've made our cuts, the numerator tells us how many of those sections to travel, or maybe an easier way to think of it is how many jumps to take, always starting from 0.
So, this is the really crucial point. Just remember this, the denominator tells you how many cuts to make, it creates the equal parts. The numerator tells you how many jumps to take along those parts. They have two very different, very important jobs.
Okay, enough with the theory. Let's actually take a trip and find a fraction's exact address on our number line map. Let's see how this works in the real world.
We're looking for the fraction 3/4. So let's just follow the steps. Step 1, we draw our line, mark our start at 0 and our end at 1. Easy. Next, step 2, we look at the denominator. It's 4. That means we split the space into 4 equal parts. For step 3, we can label those new tick marks, 1/4, 2/4, 3/4. And finally, step 4, the numerator is 3. So we start at 0 and we make 1, 2, 3 jumps. And there it is. That exact point is the address for 3/4. Now this is where it gets really interesting. This number line map, it reveals secrets about fractions that the pizza model just can't show you. It shows us that some fractions have like secret identities. Mathematicians call them equivalent fractions. Okay, let's start with a new, clean number line from 0 to 1. Finding 1/2 is pretty easy, right? The denominator is 2, so we make 2 equal parts. The numerator is 1, so we take 1 jump. And it lands right in the middle.
Okay, don't erase anything. On that very same line, let's find 2/4. The denominator is 4, so we need 4 equal parts. The numerator is 2, so we take 2 jumps from 0. 1, 2. Okay, take a close look. We just located 2 different fractions, 1/2 and 2/4, on the same line. Do you see where that second one, 2/4, ended up? They land on the exact same point. And this right here is the big idea. Even though 1/2 and 2/4 look completely different, they represent the exact same number, the same value, the exact same address on our map. And this is what we call equivalent fractions. They're fractions that are written differently but of the same size, and they live in the very same spot on the number line. So 1/2 is the same as 2/4, which is also the same as 4/8, and you could keep going forever. So why do we ditch the pizza for the number line? What is the big takeaway here? Well, it's about seeing fractions for what they truly are. Let's just recap the most important points. Fractions are not just pieces. They are numbers with a precise location. That location is found on the number line using the denominator for the cuts and the numerator for the jumps. And most powerfully, any fractions that land on the very same spot are equivalent. They are the same number. And this isn't just a neat trick. Understanding that fractions are numbers on a line is the foundation for everything else you'll ever do with them, from adding and subtracting to working with decimals and percentages. This one shift in perspective really does change everything. It opens up a whole new way of understanding, comparing, and working with fractions. Which, leaves us with a pretty fascinating question to think about.
If this whole world of fractions lives in that tiny space between 0 and 1, what else could be hiding further down the line?